Homework 3 starts off with adding rational expressions with different denominators. And it says on the first one there we have to subtract. And so when we add and subtract fractions, we have to have a common denominator. In this case, we have an 8x and a 6x. Our common denominator is going to be 24x because the least common multiple of 6 and 8 is 24. So 8x would go into 24x 3 times. I would take 3 times the top of that expression. So I would have 18x minus 15. And then 6x goes into 24x 4 times. But be careful here. I have that minus sign in front. So think of it as minus 4 times 3x minus 4 because I've got to distribute that negative sign out as well as the 4. So I'm going to have negative 12x plus 16. So just bring that sign down in front of that number that you're going to multiply by, and that way you don't forget to change the signs if it happens to be negative. You're now going to combine your like terms. 18x minus 12x would be 6x. Negative 15 plus 16 is plus 1. My common denominator was the 24x. Now we're just going to leave it as a fraction like that. You can't reduce it down unless all 3 terms are divisible by the same thing so that you can factor that number out. In this case you can't, so that's going to be your answer, 6x plus 1 over 24x. So if I look at number 2, if I have denominators of 9c and 2c, my common denominator then is going to be 18c. 9c would go into 18c 2 times, so I'm going to take 2 times the top. I'd get 16c minus 6 then. 2 goes into 18 9 times, so this is a plus on this one, so plus 9 times that 2c minus 1 since I don't have room to smush it in there. If I multiply that out, I'm going to get a plus 18c, and a positive 9 times a negative 1 is a minus 9. So I'm going to combine my like terms, 16c plus 18c. If I add those together, I'm going to get 34c. Negative 6 minus 9 would be minus 15 over my 18c. Again, I can't reduce it unless I can divide all 3 terms by the same thing, which I don't think I can do, so that should be my answer. And the third one, same thing. I'm finding my common denominator. In this case, I can just use 6a since 3 divides into 6. And so 6 goes into 6 1 times. 1 times the top would give me 9a minus 4. 3 goes into 6 2 times, but there's a minus, so minus 2 times the 4a minus 1 would give me minus 8a plus 2. So be careful with that negative sign when you have the subtraction. 9 minus 8 gives me a. Negative 4 plus 2 is minus 2 over my 6a. And so a minus 2 over 6a would be my answer. So find my common denominator, make my equivalent fractions by multiplying, and then go ahead and combine your like terms. 4, 5, and 6, adding rational expressions with multivariate monomial denominators. Again, we're adding and subtracting fractions, so we have to find our common denominator by finding that least common multiple. So if I'm going to find my common denominator here, the least common multiple of 12 and 9 would be 36. And then with my variables, I have to use the higher one. I have a d to the third, but no d's, so I have to have the d to the third. I've got a k to the third and a plain k. I've got to have the higher one, k to the third. And even though this doesn't have c's, this does have a c, so I have to have a c. So I have to have 36, d to the third, k to the third, c as my common denominator. So I'm thinking about, what do I take times this denominator to get this? Well, 12 times 3 is 36, so I would need a 3. D to the third I've already got, k to the third I've already got, but I don't have the c. So I have to take 3c times what's on top of that fraction, which is going to give me c3 to the third, w to the third. On the other one, we've got that plus sign there. 9 goes into 36 4 times. I don't have the d to the third, so I need the d to the third. C I've got a k, but I need k to the third, so I need k to the second. So I want to multiply that by what's up there, so I'm going to have a 16 d to the third, k to the second, and then that y cubed that was already up there. Now those are not going to be like terms, so that's just going to end up being your answer, as weird as it looks. Smush that in kind of close. So 3c to the third w to the third plus 16d to the third k squared y cubed over 36d to the third k to the third and c. And again, your order of your variables can be switched around. It would be the same thing. So number 5, we're doing subtraction. Same thing. I want to start by finding my common denominator. I'll write it over here a little bit farther. Least common multiple of 9 and 3 would be 9. Got an a to the third, no a's there, so I need a to the third. I've got a b to the third, no b's there, so I have a b to the third here. I've got a c squared and a c to the third. I need the higher one, so the c to the third. So 9, a to the third, b to the third, and c to the third would be your least common multiple. So I've already got the 9, I've already got the a to the third. I need a b to the third. And I have a c squared, but I need a c to the third, so I need another c. So times what I've got up on top there, I'm going to get b to the fourth cu. Minus. And on the other one, I need to take 3 times 3. I need the a to the third. I've got the b to the third and the c to the third. So I'm going to take 2 times 3, so I'm going to get 6 a to the third b squared, and that crazy looking thing is going to end up being my answer. So number 6, again, I'm going to find my common denominator here. If I have a 9 and a 3, I've got to use the 9 because 3 divides into 9. Looking alphabetically, I've got a c to the third but no c's, so I'm going to have a c to the third. I've got a d squared, but no d's there, so I'm going to use the d squared. I've got a k and a k squared. I've got to use the higher one, k squared. So making my equivalent fraction, I've got the 9. I need the c to the third. I've got the d squared, and I only have one k, so I need another k. So I'm going to get 5c to the third k u cubed. And again, if you put your variables in a different order, that's fine. Minus, on the other part, 3 goes into 9 3 times. I've got the c to the third and the k squared, but I need the d squared. So 4 times 3 is going to give me 12. I'm going to have a d to the third times a d squared, which is d to the fifth. And then I've got a v to the third. So 5c to the third, k u to the third, minus 12d to the fifth v cubed over 9c to the third d squared, k squared. These ones you probably want to hit the fraction button first before you try to type it in. If you try to type in the top, you're going to have to highlight it before you hit the fraction button, otherwise it'll just put it underneath that end term and not both terms. So either hit the fraction button first or type the top, click and drag to highlight it, and that will underline the whole thing. 7, 8, and 9, we're still adding and subtracting rational expressions, so we still have to find the common denominator. In this case, these two denominators are not going to have anything in common, so it's like having a 2 and a 3 and saying, oh, 2 times 3. We're just going to leave it in factored form, but on our common denominator, we're going to have 8x times 6x minus 7. And I just put the 8x first since it was a monomial. Looks prettier that way. So what happens is I end up taking the first one times the 8x. 8x times x is 8x squared. The second one I'm going to take times the 6x minus 7. Again, I've got to keep in mind that that minus sign is in front of that, so I'm going to put the minus and then I'm going to put parentheses because I'm going to want to distribute that negative sign out. But here, since I have two terms on the top and two terms that I'm going to multiply, I end up foiling. X times 6x is 6x squared. X times a minus 7 would be minus 7x. Negative 1 times 6x is a minus 6x. Negative 1 times a negative 7 is a plus 7. So the negative 7 and the negative 6 would be minus 13x in the middle. So I'm going to have 8x squared, and then I'm going to have a minus 6x squared. That's going to change to a positive 13x, and that's going to be minus 7. The denominator is going to stay the same, but here I can combine my 8x squared and my minus 6x squared, so I'm going to have 2x squared plus 13x minus 7 over my denominator, which is the 8x times 6x minus 7. And that's what I'm going to put in for my answer. Again, I would probably hit the fraction button first and type the top separately from the bottom, just because it's easier to get in on the ALEKS program. So on my next one, my common denominator there, I'm going to have the x times the x minus 2. So this first one I'm going to take times x, so I'm going to distribute that. X times x is x squared. X times a positive 6 is a plus 6x. Here again I have that minus sign, so I'm going to put the minus and then the parentheses, so I remember I have to change all my signs. I have to take this one times the x minus 2, so I'm going to FOIL that out. X times x is x squared. I'm going to have a minus 2x on the outside, a minus 7x on the inside, and then a minus 7 times a minus 2 is a plus 14. Here, negative 2 minus 7 would be minus 9x in the middle. So I'm going to have x squared plus 6x, and then I'm going to distribute my negatives. So minus x squared plus 9x minus 14, and that's all going to be on top of my fraction. Combining my like terms, my x squareds are going to cancel. 6 plus 9 is 15x minus 14 over my denominator, x times x minus 2. Number 9 then, my common denominator on this one, I have to have both the x plus 4 and the x minus 2. So the first one I'm going to take times the x minus 2. So I'm going to get 4x squared minus 8x. This one has a plus, so I really don't need the parentheses. I could put them there, but the plus isn't going to change the signs. But I have to take this one times x plus 4 here. So I'm going to have a 5x squared plus a 20x. So combining my like terms, 5x squared plus 4x squared, 9x squared. Negative 8x plus 20 would be positive 12x. And then I'm going to have my x plus 4 times my x minus 2. So when my denominators aren't in common, then I just have to use them both and then just multiply by the opposite ones. And there's my answer. All right, we are adding rational expressions involving different quadratic denominators. And when we add fractions, we have to have a common denominator. So our first step is that we're going to factor out our denominators so we can see what we have in the denominator. So if I factor this first one here, 3x squared would be 3x and x. Since my end is negative, I know I'm going to have one plus and one minus. I have 1. I know it's going to be a 1 and a 1. So since I want a plus 2, I need to have a plus here and a minus there. 3x minus 1x is 2x in the middle. Factoring my second one, 3x and x. This time my end is a positive, so I know they're both going to be a minus and a minus. And again, factors a 1, 1, and 1. So one denominator has 3x plus 1. The other one has 3x minus 1, 3x minus 1 times x plus 1, and 3x minus 1 times x minus 1. So my common denominator, I have the 3x minus 1 and the x plus 1 from my first fraction. Here, I'm going to have the 3x minus 1 already in my denominator, so I don't need it again. And then I need the x minus 1. So I'm just simply going to make my equivalent fractions. Here I have those two factors. I still need the x minus 1 factor. Here I have this factor and this factor. I still need the x plus 1 factor. So basically I'm just going to use my distributive property there on the top of my fractions. Be careful if this is a minus, because that would make that a minus 2 instead of a plus 2. It's a plus, so I'm all right. I'm going to multiply that out. So 4 times x is 4x. 4 times a minus 1 is minus 4. Positive 2 times x is a plus 2x. Positive 2 times a positive 1 is a plus 2. I'm then going to just combine my like terms. So 4x plus 2x is 6x. Negative 4 plus 2 is a minus 2. And that's over my whole denominator. 3x minus 1, x plus 1, and x minus 1. Now, I might be done at that point, but I'm not sure. What I need to do is factor my numerator, if I can, to see if I have any common factors that I can cancel out. In this case, I can divide both of these by 2, and that leaves me 3x minus 1. So I can see there that the 3x minus 1 is common to the top and the bottom. I'm going to be able to cancel that out. So my answer is going to be 2 over x plus 1 and x minus 1. Now I don't need to FOIL that out. I can just leave it in factored form. That's going to be perfectly fine. And so that's what I'm going to enter in for my answer. Number 11, again, we're adding. We have to find our common denominator. So again, we're going to start by factoring. 3x and x. Since that's a plus on the end, we know our signs are the same, a negative and a negative. Factors of 21, I want to get 16. So I don't want to take 3 times 7. That's too big. I'd have to do the 7 here and the 3 here. Negative 9 minus 7 is negative 16 in the middle. Notice that that x minus 3 is in both of my denominators, so I don't need it more than once. So my common denominator is just going to be the 3x minus 7 and the x minus 3. So on that first fraction, I don't have to multiply that by anything. I could say it's times 1, but I'm just going to get the 2. The second fraction is missing the 3x minus 7. So if I multiply that by 1, I get 3x minus 7. Combining my like terms, then I get 3x minus 5 over my 3x minus 7 times x minus 3. And I can't factor that out, and I can't reduce it down any farther than that. So that's just going to be my answer. Number 12, again, we have to factor our denominators out so we can find out what our common denominator is. So factoring here, 3x and x. Since the end is negative, we've got 1 plus and 1 minus. I want to have a 7 and a 1, so I'm going to put those in first so I get my signs the right way this time. I want a minus 4, so I'd have to have a minus 7 and a plus 3. And that should give me the 3x squared minus 4x minus 7. On the other one, we've got 3x and x. Both of these are pluses. And so for 28, we would have 4 times 7. Whoops, not pluses. Both of those are minuses. Since the end is positive, they're both the same as the middle. I didn't even look to see what the middle is. They're both minuses. And so 4 and 7, I would have to have a minus 4 here and a 7 there, so that I get negative 12 minus 7, which is negative 19. So on this one, our common denominator is going to have the 3x minus 7, the x plus 1, and the x minus 4. So on the first one here, we're going to multiply by the x minus 4, and on the second one, we have to multiply by the x plus 1. So we have 2x minus 8. Now this one has the minus sign, so we have to remember to put our parenthesis there. And 1 times x plus 1 is x plus 1, but then we have to distribute that, so it's going to be negative x minus 1 when we get rid of the parentheses. So 2x minus x is x. Negative 8 minus 1 is minus 9. And then our denominator, 3x minus 7, x plus 1, and x minus 4. And all of that then is going to go in for your answer. The next ones, we have a complex fraction with quadratic factoring. A complex fraction basically is just a division problem. This is the same thing as having v minus 6 over 2 divided by v squared minus 36 over 14v. So we know that when we divide fractions, we end up inverting and multiplying. So we're going to have v minus 6 over 2 times 14v over v squared minus 36. So in this case, again, I want to solve by factoring so I can cancel out my common factors. There's not a lot of factoring I can do other than this quadratic expression, which is my difference of squares, v plus 6 and v minus 6. So when I'm canceling here, I can cancel out the v minus 6's. And I can do a little bit more canceling because I have the 2 and the 14. 2 goes into there once and into there 7 times. So what I have left on the top of that fraction is 7v, and what I have left on the bottom is 1 times v plus 6, which is this v plus 6. And so my answer, 7v over v plus 6. So again, as long as I remember this is a division problem, I'm going to invert and multiply. So I'm going to say w minus 4 over w squared minus w minus 2 times the reciprocal, so the w minus 2 over 4, and save myself a step in there. Again, I need a factor, and the only thing I can factor is this quadratic expression here. W and W, a plus and a minus. Factors a 2, I want a minus 1 in the middle, so I need a minus 2 and a plus 1. So the only thing I can cancel here is the W minus 2. I can't cancel the 4's because there's that W minus 4 goes all together. It's not just a plain number. And so in this case, my answer, I have W minus 4 on the top. And on the bottom, I'm going to have 4 times W plus 1 because it looks prettier. I'm putting the 4 in front, and that's going to be my answer. Number 15, again, we're dividing fractions here. We have a complex fraction, a fraction divided by another fraction, so we're going to have y minus 4 over 5y squared. We're going to multiply by the reciprocal, so 35y to the 4th. Over y squared minus 8y plus 16. Again, we can't do a whole lot of factoring, but we can factor the bottom of this one. Y and y, since the end is positive, they're both the same as the middle, a negative and a negative. Factors of 16 that add up to 8, 4, and 4. So we can cancel out one of the y minus 4's, not both of them on the bottom. And then we can do some reducing on this other one. 5 goes into here once and into here 7 times. Y squared cancels out, leaves us a y squared up there because 4 minus 2 is 2. So on the top, we have a 7y squared. On the bottom, y minus 4. 16, 17, and 18, complex fractions made of sums involving rational expressions, problem type 2. Now when I have fractions within fractions and they're not all one big fraction and all of that good stuff, what I need to do is get rid of all the extra fractions, and the easiest thing to probably do is just to multiply by the common denominator so that you can simplify the top and the bottom. In this case, I have a denominator of x plus 4 on both the top and the bottom. So I'm going to multiply every term on the top by x plus 4 and every term on the bottom times x plus 4. So x plus 4 here, almost looks like a plus sign. Try that again. X plus 4 here, x plus 4 here, x plus 4 here, and x plus 4 here. So on the top, 1 times x plus 4 is going to give me x plus 4. Here I'm going to cancel out the x plus 4, so I'm going to get minus 2, which gives me x plus 2 up on the top. On the bottom, the x plus 4's cancel out, so I get a 4. And then I'm going to multiply by a positive x, so plus x squared plus 4x. So I'm going to have x squared plus 4x plus 4. Now again, I want to make sure I can't reduce that, so I'm going to factor the bottom, since that's a quadratic expression. That factors into x and x, a plus and a plus, factors of 4 that add up to 4, 2 and 2. You can see that one of my x plus 2's is going to cancel out. I'm saying this goes into here once and this goes into there once. So my answer, 1 over x plus 2, is then what I'm going to put in for my answer. So number 17, same thing. You'll notice you have the x minus 3 in the denominator of both of those fractions. I'm going to multiply every term by that x minus 3. So on the first fraction, that's going to cancel out the x minus 3. I'm going to get 2 plus x squared minus 3x. On the bottom, the x minus 3 cancels out. I get 1. And multiplying that out, I'm going to get 1x minus 3, or x minus 3. So on the top, we have x squared minus 3x plus 2. On the bottom, we're going to have x minus 2. So again, I have to check to see if I can reduce that at all. Factoring the top, x and x, the end is positive, so both are the same as the middle. Factors of 2 that add up to 3, 2, and 1. So again, I'm going to be able to reduce. It goes into there once and into there once. So I'm going to have x minus 1 over 1, which is this x minus 1 then, for my answer. So number 18, same kind of problem. I've got those fractions within my fraction, and I can multiply by that x minus 2 to get rid of some of those fractions. So if I multiply everything by x minus 2, on the fractions I can cancel. So I'm going to get 27 plus, and multiplying that out, I'd have 9x minus 18. On the bottom, again, I canceled, so I get the 24 on top of the fraction, and multiplying that out, plus 8x minus 16. So on the top, we have 9x, 27 minus 18 is plus 9, and on the bottom, we have 8x, and 24 minus 16 is 8. We can factor those. If I factor the 9 out of the top, we get 9 times x plus 1. If I factor the 8 out of the bottom, we have 8 times x plus 1. So when we reduce that, canceling out our x plus 1's, we just get the fraction 9 over 8. (19 through 21) rational exponents. We're going to have both negative and positive ones with a fractional base. So just reminding you that when I have a fractional exponent, I rewrite it as a radical expression. 1/9 to the 3/2 power means I'm going to have the 1/9, and I'm going to do the square root of that cubed. Now I really didn't need all that parentheses and stuff, but just so that you can see where everything went, the denominator, the fraction, is the index to my radical. The numerator stays with my fraction. Now you could cube that first, but then your number would be kind of big. So it's easier to do the square root first. The square root of 1/9 is going to be 1/3, because the square root of 9 is 3. I'm then going to cube that, and so 1/3 cubed is going to be 1 over 27. Now you'll notice on the Alex program, they don't always put the parentheses, and they just put the exponent with the number that's not a 1, because 1 to any power stays 1, so you really don't have to think about 1 to the 3rd as 1. You're just doing the 3 to the 3rd is 27. If I'm doing that on my calculator, I have to be careful and use parentheses around the fractions. So I would do 1/9 to the 2/3 power and put both of those fractions in parentheses for the calculator to figure that out correctly. Now, remembering on this one, if I have a negative exponent, we have to do the reciprocal of the base first. So this one is rewritten as 1/32 to the positive 4/5 power. So I do the reciprocal of the base first. Now I do it like I do the previous one. So I'm going to do the 5th root of 1/32 raised to the 4th power. Doing my 5th root first, the 5th root of 1/32 would be 1/2. 5 times 5 times 5 times 5 times 5. 5 to the 5th power is 32. So 1/2. And then I'm going to do the 1/2 to the 4th power. 2 to the 4th power is 16. So I get 1/16. So first answer was 1/27. The second one was 1/16. On the next one, same kind of thing. I look here first and say, oh, there's a negative exponent. Whenever there's a negative exponent, I have to do the reciprocal. So 1/81 to the 3/4 power is what I'm going to calculate. The 4th root of 1/81 cubed then. The 4th root of 81 is going to be 3. 3 times 3 times 3 times 3 is 81. So 1/3 to the 3rd power gives me 1/27. Now, if you don't have your powers memorized, you may want to make a table, do all your squares, do your cubes, do some 4th powers, and probably 2 to the 5th, maybe 3 to the 5th is about as big as you're going to do. But the 5th power, the most common one, is the 5th root of 32 is 2. Number 20, the second part is the same kind of thing here. Again, I have that negative exponent, so I have to do the reciprocal. The reciprocal of 1/32 just makes this 32 to the 3/5 power. Again, I really don't need the parentheses, but hey, I put them there. So I'm going to do the 5th root of 32, and then I'm going to cube that answer. The 5th root of 32 is 2, and 2 cubed going to give me 8 for my answer. In all of these, you should be able to punch into your calculator and check. Just make sure you're putting parentheses around the fractions when you put them in your calculator. So number 21 here, again, I have 32 to the negative 3/5 power. Since my exponent is negative, I have to do the reciprocal. So I make it 1/32 to the positive 3/5 power. Now that my exponent is positive, I can go ahead and calculate that out. So the 5th root of 1/32 cubed is my problem. The 5th root of 1/32 would be 1/2. And then if I take 1/2 and cube it, I'm going to end up with 1/8. And the next one there, I'm going to do 1/16 to the 3/2 power. Notice this time my exponent is positive, not negative, so I'm not going to flip it over to start with. I'm just going to do the square root of 1/16 and raise my answer to the 3rd power. So the square root of 16 is 4, so square root of 1/16 is 1/4. 1/4 raised to the 3rd power, 4 to the 3rd power is 64. So 1/64 going to end up being my answer. (22 to 24) rational expressions, products and quotients with negative exponents. Now, if I have it all written as a product with the same base, my rule is to go ahead and add the exponents. So if I have x to the negative 2/3 times x to the negative 1/3 times x to the 1/6 power, I'm just really adding and subtracting those fractions. So I have to have a common denominator. I'm going to write it as x to the, and I'm going to have negative 2/3 minus 1/3 plus 1/6, which means I have to find my common denominator. So I'm going to have x to the, and my common denominator there would be 6's, making my equivalent fractions. 3 goes into 6 2 times, so 2 times negative 2 would be negative 4. 3 goes into 6 2 times negative 1 would be minus 2. And then 6 goes into 6, 1 times 1, going to give me plus 1. So negative 4 minus 2 plus 1 would give me negative 5/6. Now if I get x to the negative 5/6 and I want to write my answer using only positive exponents, I then have to do the reciprocal, so my answer becomes 1 over x to the 5/6 power. Write that exponent a little better. Now, you can try to read that. 1 over x to the 5/6 power. Now, here I have a division in with my multiplying. So what I want to do is basically move these two things up to the top. And when I move them up to the top, it's going to change its sign. So I'm going to have y to the 1/3 times y to the, this is going to become negative 1/4. And this is going to be y to the positive 3/4. So when I moved it from the bottom to the top, I had to do the reciprocal, which changes the sign of the exponents. Now again, I'm doing my adding and subtracting. So I'm just going to go ahead and find my common denominator. In this case, it's going to be 12. 3 goes into 12. 4 times 1 is 4. 4 goes into 12. 3 times minus 1 is minus 3. 4 goes into 12, 3 times 3 is 9. So I have 4 minus 3 plus 9, which gives me y to the 10/12. Now this one I have a positive exponent, but I can reduce my exponent, so I would want to do that. So I would say y to the 5/6 power, and that's going to end up being my answer. Since the exponent is positive, I don't need to do anything else with it. Number 24, same kind of thing. I've got that one that's down on the bottom. I've got to move it up to the top by changing its sign. So I'm going to have a to the 3/2 times a to the minus 1/4 times a to the, and that's going to become a negative 1/3. My common denominator on that one looks like, again, I could use 12. And so 2 goes into 12. 6 times 3 is 18. 4 goes into 12. 3 times minus 1 would be minus 3. 3 goes into 12. 4 times minus 1 would be minus 4. So 18 minus 3 minus 4 would give me 11/12. So a to the 11/12 is going to be my answer. Now it looks normal. Make sure you write it so that exponent is raised, not right behind there. Otherwise it looks like a times 11/12, not a to the 11/12 power. That should be your exponent. 25 through 27, we are doing rational exponents, powers of powers with negative exponents. And again, reminding you that when you raise to a power, that you multiply the exponents. Now you can either multiply first or get rid of the negative exponents first. I'm going to go ahead and get rid of the negative exponent first. So this is really going to be a to the 5/4 over b to the 5th power. I'm then going to go ahead and raise that to the 1/5 power. When I raise it to the 1/5 power, I'm multiplying the exponents. So I'm doing a to the 5/4 times 1/5. 5s would cancel out, gives me a to the 1/4. On the bottom, b to the 5th times 1/5. The 5s would cancel out. I get b to the 1st power, which is just a b. So I get a to the 1/4 over b for my answer. So the next one again, it has that negative exponent. I'm going to get rid of that first. And so I'm going to write it as b to the 2/5 over c to the 1/5. I'm going to raise that to the 3rd power. So I'm going to take b to the 2/5 times 3 over 1, which would give me b to the 6/5. And then I'm going to take c to the 1/5 times 3 over 1, which gives me c to the 3/5. And that's going to end up being my answer. 27, you notice the exponent on the outside is negative. The exponent on the outside is negative. I have to do the reciprocal by putting 1 over c to the 1/4 a to the 5th. And now I'm going to raise it to the 2/5 power. Well, 1 to any power is going to stay 1. And then I'm going to multiply my exponents. So 2/5 times 1/4 would be 2 over 20. 2 over 20 would reduce down to 1/10. 5 times 2/5, 5 times 2 is 10. 10/5 is just going to give me 2. So a to the 2nd power. So 1/4 times 2/5, that would cancel. I get 1 over 10. And 5 over 1 times 2 over 5, it cancels out. I get 2 over 1, which is 2, for those who you need some practice at doing their fractions. That is the end of homework 3.